As one year ends and another begins, we look forward, counting days, making promises, measuring time. But the universe does not count years the way we do. For dark matter, a year is nothing. A millennium is a heartbeat. While we celebrate a new beginning, the shadow element continues its silent work, unchanged, unseen, eternal. Every new year carries questions we have not answered yet. And among the greatest questions waiting in the dark is this: what is most of the universe made of? As the calendar turns, the shadow element remains, inviting us to look deeper than light itself. The universe is not what it seems. Look up at the night sky and everything you see, every star, every glowing galaxy, every planet and nebula, all of it together makes up less than 5% of reality. The remaining universe is hidden, silent, invisible. It does not shine, it does not burn, and it does not reflect light. Yet it controls the motion of galaxies and shapes the largest structures ever formed. This is the story of dark matter, the shadow element of the cosmos. Long before scientists knew its name, the universe was already revealing its secret through motion. In the early 20th century, astronomers began measuring how fast galaxies move inside massive clusters. What they found made no sense. The visible matter simply was not enough to hold those galaxies together. According to gravity, they should have flown apart long ago. But they did not. Something unseen was binding them. An invisible mass. A hidden weight pressing down on the cosmos. At first, the idea was uncomfortable. Science prefers what can be seen, measured, and touched. An invisible substance sounded too much like mystery, too much like speculation. But the evidence refused to disappear. The faster astronomers looked, the stranger the universe became. Then came the spiral galaxies. When scientists measured how stars orbit the centers of galaxies, they expected stars farther out to move more slowly. That is how gravity works when mass is concentrated in the center. Instead, the stars moved at nearly the same speed no matter how far they were from the core. It was as if galaxies were wrapped in massive, invisible halos. Vast oceans of unseen matter extending far beyond what telescopes could detect. This was no longer a small anomaly. It was everywhere. Dark matter was not just present. It was dominant. To understand dark matter, we must first understand what it is not. It is not ordinary matter. It is not made of atoms like stars, planets, or human bodies. It does not interact with light, which means it does not emit, absorb, or reflect it. That is why it is dark. But dark does not mean empty. Dark matter has mass. It responds to gravity. It bends space-time and pulls on galaxies with immense force. Without it, the universe as we know it could not exist. In fact, dark matter may be the reason galaxies exist at all. In the early universe, moments after the Big Bang, everything was hot, dense, and chaotic. Ordinary matter struggled to clump together because radiation pushed it apart. Dark matter, unaffected by light, began to gather first. It formed invisible scaffolding across the universe. Later, ordinary matter fell into these gravitational wells. Gas condensed. Stars ignited. Galaxies were born. Dark matter did not build the universe by shining. It built it by pulling. Even today, galaxies drift along vast cosmic filaments shaped almost entirely by dark matter. These filaments connect clusters across billions of light years, forming a structure known as the cosmic web. If you could see dark matter, the universe would look completely different. Bright galaxies would appear like glowing dewdrops clinging to invisible threads stretching across eternity. Yet despite its importance, dark matter remains one of the greatest mysteries in science. We do not know what it is made of. Scientists have proposed many candidates. Exotic particles that pass through ordinary matter without leaving a trace. Particles that rarely interact, hiding from detectors deep underground. Some theories suggest new types of physics beyond everything we currently understand. Experiments around the world are trying to catch even a single dark matter particle. Detectors buried beneath mountains. Instruments cooled to near absolute zero. Observatories watching the sky for subtle distortions caused by its gravity. So far, dark matter has remained silent, and that silence is part of its power. One of the strongest pieces of evidence for dark matter comes from gravitational lensing. Massive objects bend light as it travels through space. By observing how distant galaxies appear warped and stretched, scientists can map where mass exists even when it cannot be seen. These maps reveal enormous concentrations of invisible matter drifting through the universe, colliding, merging, and reshaping reality on cosmic scales. In some galaxy collisions, dark matter separates from ordinary matter entirely. Gas clouds slow down and heat up, while dark matter passes straight through, unaffected. This behavior tells us something profound. Dark matter is not just unseen. It is fundamentally different. It does not collide. It does not stick. It does not glow. It only pulls. And yet, without it, stars would scatter, galaxies would dissolve, and the universe would become a thin, lifeless fog. There is a strange irony in dark matter. The more we learn about the universe, the clearer it becomes that most of it is invisible. Human perception evolved to survive on a small planet around an average star. We were never meant to see the true structure of reality. Dark matter exists beyond our senses, beyond our intuition. It reminds us that knowledge is not limited by imagination, but by humility. Some scientists once believed dark matter might be an illusion, a flaw in our understanding of gravity itself. Alternative theories were proposed, attempting to explain cosmic motion without invoking invisible matter. But over time, observation after observation pointed back to the same conclusion. Something is there. Something massive. Something ancient. Dark matter has been shaping the universe for over 13 billion years. It watched the first stars ignite. It guided galaxies into place. It will likely outlast stars, planets, and perhaps even life itself. And yet, it will never look back at us. There is something poetic about that. A force that defines the universe while remaining unseen. A shadow that holds everything together. Dark matter does not care if we understand it. It does not respond to curiosity or fear. It simply exists, silently enforcing the laws of gravity on scales too large for the human mind. Perhaps one day we will detect it directly. Perhaps we will finally name its particles and write equations that describe its behavior perfectly. Or perhaps dark matter will lead us to an entirely new understanding of reality itself. Either way, it has already taught us a lesson. The universe is not obligated to reveal its secrets. The most important things may never shine. The strongest forces may never speak. And the true structure of existence may remain hidden in shadow. Dark matter is not just a scientific mystery. It is a reminder of how small our window into reality truly is. We live in a universe dominated by something we cannot see, touch, or fully comprehend. And yet, without it, we would not be here to ask the question. This is the shadow element, the unseen architect of the cosmos, the quiet force behind every galaxy in the sky. And its story is far from over.